Students, good morning. Hope you are doing good. Okay. In last class, this is chapter number, part 2 of motion in straight line, we discussed about path length and displacement. Let us consider one example given in our textbook, taking a number line or x dash axis, and try to understand what exactly is path length and your displacement, and try to write difference between your path length and displacement. You know the definition, correct? What is path length? Path length is total path traversed by a particle, an object in given interval. What is displacement? Displacement is a change in position of an object in particular direction. These two are very important. I am repeatedly telling. If you know these basic concepts, then it's very easy to develop your velocity as well as acceleration. Those concepts can be developed. Okay. We are studying motion in one dimension or rectilinear motion. We can define, we can represent this rectilinear motion using a number line or x dash axis. Let O represent origin of this axis. This is x dash in meter. Okay, let the unit be used in meter. Okay, let us take some simple numbers to understand this displacement and the path length. 0, say 20, 40, 60, 80, 100. Let me extend this. 120, 140. Okay, that is next. Of course, this plus number then, correct? X dash axis 0. This is positive. Plus. Now, here it's minus 20, minus 40. Okay. Say minus 60, minus 80. Okay. This is x dash. Once again, okay. Let us consider 3 points. Say P, Q, R. Okay. In first case, say case 1. Imagine an object which is situated at O. Imagine an object is situated at point O, is moving in this direction. From O to, this is O to R. Okay, let us consider a simple situation where an object situated at O is allowed to move from O to R. Where R is another point. What is your task? Your task is to find path length. Let me write path length as PL. Path length. What is path length? You know path length at the end it is the total distance traversed. The total distance traveled. Of course, path length is plus 140 meter. Anyway, path length is always positive quantity. No need to write plus also. No. What about your displacement? Here, displacement has certain direction. It has particular direction. So, what you have to take? If you want to write a number, you have to take what? You have to consider what? Magnitude of displacement. What? Magnitude of displacement. What is magnitude? Why we have to write like this? We will discuss these points in chapter number 4. We will discuss these points in chapter number 4, or just observe Janji sir's vector 1, vector 2. Okay, there are some very important videos sir actually uploading to you. Just observe those videos, you will understand. Okay, what are the basic things to be studied in vectors? They are very much useful to understand physics. Anyway, I will get simply displacement, but I have to use the magnitude of displacement. See, vectors, your displacement is a vector. It has both direction and magnitude. Okay. We have to represent its direction also every time. In this chapter, the motion is being in one line, I mean a straight line, rectilinear. A rectilinear motion has only two directions. Either this side, say this side in one direction, let us consider it as positive, and opposite to the direction is negative. By putting plus and minus, we can specify direction. Plus means in one direction, minus means opposite direction. If you drop some object from certain height, then the downward motion is represented by some sign, say minus, upward motion, say plus, or you can interchange. Here, no strictly what vector notations are required, because motion being one dimensional. In one dimensional motion, this is enough. Plus and minus signs are enough. Here, minus and plus sign indicate direction definitely. Hope you understand. Okay. Now, let me write displacement as, once again, it is the shortest distance or change in position. This is initial position, say x1. Now, for us, this is the final position, say x2. Change in position will be x2 minus x1, or 140 minus origin means 0. 140 minus 0 will be 140. But remember, 140 meter. Okay? Or you can write along OR. Definitely you can mention direction. You can also mention direction also. You can mention along OR. Hope you understand. And one more thing, please note that here path length is equal to displacement. This path length is equal to magnitude of displacement. Both are same. So we can have this conclusion. In straight line motion, in one dimensional motion, along a particular direction, your path length is equal to magnitude of displacement. These two terms are equal in case of straight line motion in particular direction. Please remember, seems to be easy, very important point. Okay, case 1. This is given in our textbook. These numbers are different, that's all. Just I made easy by taking some easy numbers, that's all. Now, case 2. Case 2. Your object will now move from O to R first and then R to Q. See, your object will move from O to R first, then R to Q. O to R first, O to visible, O to R first, and then R to Q. Now observe it. What is path length? path length is anyway total distance traveled by object. Total distance traveled means say OR plus RQ. OR 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 is 140 plus 6 20 20 40 correct 40 is equal to 180 meter is the SI unit of your displacement as well as path length 140 meter. Okay, no problem. Having space here? Yes. What about displacement? Displacement. Magnitude of displacement. Now, this is your x1, initial position. This is your final position. Oh, this is not final position. Your final position is now Q. It is the shortest distance between 2 points, initial and final, or final position minus initial position. Whatever what formula you use, what we get here, final position is Q, which is equal to 100, minus initial position is O, which is equal to 0, which is equal to what? 100 meter. 100 meter. We can write plus or along OQ. Along OQ. You have mentioned direction also. Now see, this path length is greater than your displacement. Your path length is greater than displacement. Remember, your path length is always greater than or equal to displacement. Case 1 it was equal, case 2 greater. Your path length is always greater than or equal to displacement. Hope you understand. Correct. Let us take one more case. Okay. Case is case 3. Case 3. From O to R, O to R, first interval, and then R to O, O to R, and then R to O, back to pavilion. What we call back to pavilion. This object, maybe bus, car, whatever, is traveling from O to point R and then R to O. What is displacement? Magnitude of displacement, you know. Magnitude of displacement is 0. Why? Why? Because your initial position coincides with the final position. Your initial position is same point and final position is same point. Net displacement is 0. There is no displacement. Okay? What is your path length? Path length is always positive quantity. It is a total. It is total distance traveled. Of course, your path length will be 140 one side and once again 140 from other side. It will be equal to 280 meter. 280 meter. This is the difference. In first case, it came to know what? Path length may be equal to what? Your displacement if motion is along straight line in particular direction. In second case, usually your path length is always greater than displacement. In third case, your displacement may be equal to 0, negative or positive, whereas your path length is always positive. Your path length is always positive. Hope you understand. Correct? I will give you a homework. You just reply me, right? Imagine a body initially, okay? I will, your body is initially at Q. X1 is its initial position, Q. And it is moving in this direction. Okay? It's your final position. X1 is its initial position, X2 is final position. Now, what is displacement? And what is path length? It's homework. You have to do it. Let me repeat. Imagine your object is a Q and it's moving from Q to P. My question is, what is displacement and what is what? Your path. Okay? Right. I think this is enough about your displacement and path length. We have discussed a lot more things. Okay? Now things are clear to you. But what is important is, the important question usually asked in examination is, differentiate between path length and what? Displacement. Write any two differences between path length and displacement. Write any three differences between path length and, okay? Very important question. Let us discuss that point. Okay? Fine. I will write here path length. Here, displacement. What is path length? I will write very important. Simply very important. Enough. Not very important. Okay. Yes. What is path length? First difference will be its definition. ಯಾವಾಗಲೂ ಡಿಫರೆನ್ಸ್ ಕೇಳಿದಾಗ ಫಸ್ಟ್ ಡಿಫರೆನ್ಸ್ ಅನ್ನ ಅವುಗಳ ರೆಸ್ಪೆಕ್ಟಿವ್ ಡೆಫಿನಿಷನ್ ಅನ್ನ ಬರೆದ್ಬಿಡಿ. ಏನ್ ಡೆಫಿನಿಷನ್? ಐ ವಿಲ್ ರೈಟ್ it is total path traversed by the particle or object. Another particle. Okay. What is displacement? It is change in position. Change in position in particular direction. In particular direction. Okay. First point is over. Second point, it is always positive. For this reason only I have taken that example. ಇದನ್ನು ಹೇಳಬೇಕಿತ್ತು. It is always positive ಅಂತ ಹೇಳಬೇಕಿತ್ತು. ಅದು ಪಾಸಿಟಿವ್ ಆಗಿರಬಹುದು, ನೆಗೆಟಿವ್ ಆಗಿರಬಹುದು, ಝೀರೋ ಆಗಿರಬಹುದು. ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ನೀವು ಕ್ಲಿಯರ್ ಮಾಡೋ ಸಲುವಾಗಲೇ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಬೇಕಾಯ್ತು. Otherwise, we have discussed a lot more things in video number 2. Think ಮಾಡಿದಲ್ವಾ? No, don't get confused. ಮತ್ತೆ confuse ಮಾಡ್ತವೆ. Okay? Now, it is always positive. Okay, second one, it may be positive, negative or zero also. Negative ಗೆ ನೀವು ಹೋಲ್ ಕೊಡ್ತೇನೆ ಕೊಟ್ಟಿದ್ದೇನೆ, I mean zero also. Very important, path length has no direction. Path length has no direction. Hence, such physical quantities are called, it is scalar quantity. Whereas your displacement is, it is vector quantity. Fourth one, you may write like path length is always greater than path length is always greater than or equal to your displacement. Your displacement is less than or equal to path length. Seems to be crazy, but if you want, then only you can write. There is fourth one, fifth one is also there. You can write fifth one also. Fifth one is like it depends on what. It depends on path traversed. It is independent of. It is independent of path traversed. Okay. Sorry. Remember, your path length depends on actual path traveled, whereas it only depends on, it is referentially independent of whatever path traveled. It only depends on initial position and final position. Initial position means starting point, final position means ending point. Say you are starting your journey at t1 is equal to 1 second at 2 meter in a graph, and your final point is t2 is equal to 10 seconds at 10 meters. Your 2 meters initial point, 10 meters final point or final position, 10 minus 2 meter, 8 meter is displacement. Like, hope you understand. These are very important things. Okay? Now, okay, it's not difference now. I'm not telling difference. Just some more things about your path length. Its SI unit is meter. SI units of your path length is meter. At the end, say path length or displacement. They are distance. At the end, they are distance, and we measure distance in terms of meter in SI unit. Displacement also SI unit is meter. What is the emission formula? See, there is no mass, okay, 1 in length, no time, simply L is what your dimension formula, length. Similarly, here too it is m0, m raised to 0, l raised to 1, 0, or is your dimension formula. Okay, you know all these things. 0 in mass, 1 in length, 0 in time. So, any number raised to 0 is equal to 1. Any number raised to 0 is equal to 1. Automatically we can write simply L. L raised to 1 means simply L. Okay? Now, during our discussions, we usually say motion is meaningless without time. We express motion with respect to time. Where we use time here? See now. Imagine you are dividing your path length by time taken. If you are dividing your path length by time taken, and you are dividing your displacement by time, then two more physical quantities you get. Two more physical quantities which you are familiar in your high school days, or whatever you have learned in your high schools. Two more physical quantities. Whenever, please remember, for simplicity I am telling, we will discuss it in what? We will discuss it in very neat manner. Okay. Your path length is divided by time, then a new physical quantity you get is called speed. Java ಕನ್ನಡದಲ್ಲಿ ಅಂತ ಹೇಳ್ತಾರೆ ಜವ ಅಂತ ಹೇಳ್ತಾರೆ. If your displacement is divided by time, you get velocity. ವೇಗ ಜವ ಮತ್ತು ವೇಗ. Two more physical quantities we are supposed to study. The first physical quantity is speed. The second physical quantity is velocity. In systematic manner. Not like in high school, we have to study here. Some extra things have to be considered here. But remember how to remember the things easily. See, as your path length is a scalar, your speed must be scalar. Remember, as your displacement is vector, your velocity must be vector. Path length is measured in terms of meter. Divide by. This is divide by. This is divide by. Divide by. Visible. Your time is measured in terms of second. Meter per second is a unit of speed. Meter is unit of path length. If you divide it by time, then meter per second will be meter divided by second will be unit of what? Your speed or meter second is to minus you can write. Similarly, your displacement we measure in terms of meter divided by time, meter per second is equal to meter second is to minus 1. These are minimum things you can remember. You can relate your displacement, your path length with speed and velocity. Your velocity is a vector quantity, remember. Why? The displacement is a vector quantity. You are dividing it by time. Okay? This year we have to study these what velocity and speed in a very systematic manner. Okay? Let's start. Let me write average speed and average velocity. Average speed and average velocity. In our textbook it is given average velocity first, then average speed. No problem. For simplicity I have taken average speed first. What do you mean by average speed? Actually, what do you mean by average? Average height of the students in a given classroom. Average marks you scored in SSLC. Average run rate in a given over. I mean, in a T20 match. In our day-to-day life, sometimes we require to calculate average values. What is average mathematically? In mathematics also we calculate average. Average means sum of all the quantities divided by total number of quantities. Say A1, A2, A3, A1 plus A2 plus A3 plus A4 plus A5 up to AN divided by N gives you average. In physics also, sometimes we use this average concept. It is helpful to understand what was the speed or velocity given interval of time, average speed. Where, let us see. Let me first consider average speed. What is average speed? See, this is town A, city A, village A, town B, town C, and this is sounding, and you are traveling in a bus, a car, no problem. Your starting point is A. This journey is divided into three equal interval of 1 hour, 1 hour, 1 hour. Remember, meter per second is a SI unit of your speed or velocity, but practically we represent kilometer per hour. ಕಿಲೋಮೀಟರ್ ಪ್ರತಿ ಗಂಟೆ. ಈ ಬಸ್ಸಿನ ವೇಗ 60 ಕಿಲೋಮೀಟರ್ ಪ್ರತಿ ಗಂಟೆ. The speed of this bus is 60 km per hour. This kilometer per hour is a practical unit of your velocity or speed. How to convert this kilometer per hour into meter per second? We will discuss it in later session. Okay. See, a bus is traveling from A to B in 1 hour. It covers around 60 km. In second interval, once again 1 hour, it covers around 70 km in 1 hour. In the third interval, it travels with the speed 50 km per hour. In these three different intervals, this is the speed taken by your bus or any vehicle. What is average speed then? We usually calculate average speed will be equal to, see, 60 km in first interval, 70 km in second interval, 50 km in third interval, divided by time taken. 1 hour, 1 hour plus 1 hour. This will be what? 60 plus 70, 130, 130 plus 50 is equal to 180. 180 kilometer divided by 30 hours. Or simply what we get? 180 by 3, sorry, not 33 per hour. What we get? 60 kilometer per hour. ಆ ಬಸ್ಸಿನ ಸರಾಸರಿ ವೇಗ 60 ಕಿಲೋಮೀಟರ್ ಆಗಿತ್ತು. ಆ ಬಸ್ಸಿನ ಸರಾಸರಿ ವೇಗ ಎಷ್ಟಾಗಿತ್ತು? 60 ಕಿಲೋಮೀಟರ್ ಆಗಿತ್ತು. This is what is the importance of our average things. By this example only we can define statement of average velocity. Then how to define this average velocity? See, this average velocity is defined as total path length. Path length in first interval, second interval, third interval. Add them, what we get? Total path length. Divide by total path length divided by total time taken. 1 hour, 1 hour, 1 hour, 3 hours. 180 km. Divide by total time taken. Total time taken. Okay. By this example only we can define the definition. Correct, everyone? Yes, correct. How to define them? Okay. How to define them? Average speed is defined as, remember, it is a ratio of, divide by, a ratio of total path length taken by an object to total time taken. Your average speed is defined as, it is a ratio of total path length taken by an object in a given interval to total time taken. Very simple definition. I have just what I have written is just definition. You can write like this. No problem. The total path divided by total time taken by an object during a journey given interval is called average speed. Hope you understand. Average speed is scalar quantity. It is always positive. Why always positive? Your path length is positive, hence your velocity, your speed will be positive always. Your speed will be positive. SI unit, we have discussed it earlier. Meter per second. What is the emission formula? Interesting. You see the dimension formula right here. Meter per second. There is no mass at all. Zero in mass. Okay. Meter L raised to 1. Okay. Divide by S means time. Correct? This is T. Or if you take this T, this is T raised to 1 also. You can write. Okay. Somewhere here I will write. See here. I will write 0 in mass. L raised to 1. If you take T, it is in denominator actually. ಅದು ಛೇದದಲ್ಲಿ ಇದೆ. ಅಂಶಕ್ಕೆ ತೆಗೆದುಕೊಂಡು ಹೋದರೆ, if you take this denominator to numerator, then T will be -1 instead of +1. This is +1. Correct? If you take this 1 to numerator, what do you get? T raised to -1. Or simply, as I discussed, m raised to 0 is 0, leave it. L raised to 1, you won't write L raised to 1. I can write L T raised to -1. T raised to -1 you must write. Okay, there is no condition for this. T raised to -1, -1 you have to know. You have to remember this. You have to remember this dimension formula. By this, we can write dimension formula of certain physical quantities like what? Your momentum. P is equal to mv, momentum, linear momentum of course, or acceleration. We will discuss. Then, where we use this velocity, force or power, we can define such things. Okay, even a force. Okay, such things we can define using the velocity. This is what average speed. In similar fashion, we can define average speed also. Let me know. So this one, average velocity also. Sorry, average velocity I am discussing. Average velocity. In our textbook, this average velocity, we are supposed to write AV and V, a small line over V called V bar. V bar represents average velocity. I am writing this average velocity in similar fashion as I have written in earlier case, as average being here total, not path length, total displacement divided by total time. What is this total displacement? The whatever displacement taken by the body. But remember, while writing the difference between your path length and the displacement, we mentioned one thing. it depends only on initial and final positions. This total displacement, whatever you may write, it only depends on initial position and final position. We can write like this: simply displacement divided by time interval. This also works good. Why? Anyway, it depends on only 2 points, on initial position and final position. Total displacement means what? There must be a final position, say x2. There has to be some initial position, minus x1. We know this very clearly. x2 minus x1 gives you total displacement. Why? It only depends on initial position and final position, independent of path traversed. It is independent of path traveled. Divided by total time. Okay. Time taken for final position, time at which object was there at final position, say t2, minus time during which object was there in initial position, t2 minus t1. This x2 minus x1 gives you what? Change. In video number 2, we know this. This change is represented by delta x. Of course, this time, change in time, is definitely represented by delta t. This is an expression for your average velocity. Remember, we can define in similar fashion, but at the end, conclusion will be what? It depends on initial position and final position. So this much is enough to represent your average velocity. How to define this? Okay. Okay, we are discussing about definition, right? Average velocity is defined as change in position, x2 minus x1 change in position or displacement delta x divided by time interval. Very simple definition. Let me see. I'm just explaining mathematical expression as a definition. Average velocity is defined as, let me repeat, listen carefully. Average velocity is defined as change in position or displacement divided by time interval. Divided by time interval. Average velocity is defined as change in position or displacement delta x divided by time interval delta t, which is exactly given in your textbook. It's textbook definition. Sometimes people say rate of change of displacement with respect to time, ratio of displacement with respect to time rate change of displacement. Okay, whatever definition you want, you can write, but this is definition. Hope you understand. Okay. Now some points regarding your average velocity, like it is vector quantity. Your displacement is vector, automatically this will be vector. It is a vector. It is a vector quantity. Okay. SI unit, meter per second. Diversion formula. Of course, LT raised to minus 1, I have done directly. LT raised to minus 1, or I have to write M raised to 0, LT raised to minus 1, visible output. Correct? One more point I want to add. As your displacement may be negative, may be positive, or zero, your velocity will be, average velocity will be, maybe right, maybe positive, no, not good, positive, negative, or zero. It's positive, negative, or zero. Okay? Here too, you may ask to write any three differences between average velocity and average speed. Write any three differences between average velocity and average speed. Okay? I will just, it's already 46 minutes, okay? I will just tell you, you have to write. You have to practice it. Okay? Of course, we are moving in little slow motion. Motion is straight line in slow motion. It is helpful if you understood once things will be very much clear. Then we can move fast, right? No problem. Okay. Even this is not it. Right? Let me write velocity here. Okay. I will write average velocity only, no problem. Average speed. First thing, I will just explain these things. Definition, average velocity. It is change in position or displacement with respect to time, or change in position or displacement divided by time interval. Average speed. It is defined as total path length taken by an object divided by total. It is defined as it is a total path length traveled by the body divided by total time taken. Or it is a ratio of total path traveled by the body to total time taken. First thing. Second thing, your velocity is vector. Your velocity is vector. Your average speed is c. Second one is vector. Vector quantity. It is scalar quantity. Third one. It may be positive, negative, or zero. Here, average speed it is always positive. First one, of course, definition. As I said, definition you have to write here. Definition you have to write here. Okay. Okay. Yes, definition you have to write. This you are enough to remember. Next period, in next session, we are supposed to study instantaneous velocity and instantaneous speed, where we need to know some differential calculus. Limit. What is the concept of limit? Let us see whether to skip that portion, I mean that mathematical portion, or we have to have one class on simply on mathematics. I discuss with my senior. Okay, no doubt. Okay. Let's stop here. In next class, let's also do some problems to differentiate your average speed and average velocity. Okay, one or two problems can help you understand these two concepts better. Okay, what you have to do at the same time, go through the video and go through the notes. Today, once again, I will put notes. Okay, write them very neatly and read them, study them, study the notes, all subject. Okay. Thank you for watching the video. Thank you. Next.